In this problem, there is a uniform electric field in the XOY plane represented by 40I plus 30J volt per meter. If the electric potential at the origin is 200 volts, the electric potential at the point with with coordinates 2 meter 1 meter is. So our motto is to find the electric potential at the given coordinates. So there is an XY plane. So in that there is an uniform field is passing like this. So this is uniform field E, and you have a potential at origin. We have a potential at origin that is equal to 200 volts. So you need to consider the potential at some point where it is coordinates is 2 meter and 1 meter. So here you need to find the potential. So the potential at 2, 1 you need to find out. So that is our motto. Now I'll investigate the things what I've given. The electric field, parallel electric field E is equal to 40 I cap plus 30 J cap volt per meter is the parallel field, and the potential at origin VO is equal to, or V00 I'll write, VO is equal to 200 volts, and the point where we need the potential is, the point is 2 meters 1 meter, that is the point. So we need to find out V2 1. So if we consider a point like this in the field, we need to find out the potential at that point. So that is our motto. Now I'll move to the resolving part. So while resolving, listen carefully. So this is a parallel field. So I have a parallel field like this. So in the whenever the parallel field exists, the plane through which the field is passing will consider as a equipotential plane. That means whatever the point on the plane, the potential is same. So whatever, if you consider any point on this plane, the potential is same. So that is called equipotential surface. So same like that, if you consider it is as 1, if you consider another plane like this which is some distance d apart from the previous one, there will be a potential V2 which is also having equipotential surface, but when compared to the other surface it will slightly differs. That means there is no equivalence between these two. So for a field, for a uniform field, if we consider 2 points on 2 different planes, they will have 2 different potentials. So here also there is an origin, there is a potential at origin. So assume that the origin is here. There is a potential at origin, and you need to find out a potential at some other point like this. So that means we need to find out the potential difference. Actually the question is, we need to find out the potential difference, the electric potential at the point with the coordinates 2m 1m is, that means potential at this point. So according to the definition, what is the electric potential difference to exact potential difference to work done to move a charge from one point to other point? So that means, can I consider like V1 minus V2 is equal to E bar dot product D bar or R bar we can consider. So why? Because this is a vector and D is a vector, and the dot product of that two gives a scalar where the potential is also a scalar. Here look at this, there is a concept like whenever you are considering a parallel field like this, so when you are going towards the direction of the field, the potential will decrease. So V1 is, so from this figure we can write V1 is greater than V2. So if you take the difference V1 minus V2, that is equal to, you will get a positive quantity. So here also E into D. So V1, here V1 is V0, V00, and V2 is V21, that is equal to E dot D. What is D then? D is a position vector from the origin to the given point, this point. So D vector can be written as 2 I cap, because 2 meters in x direction, plus 1 meter in j cap, 1 meter in y direction. So j cap 2I plus j. So that is equal to here 40 I cap plus 30 j cap with a dot product with the with 2 I cap plus j cap. So what is V00? It is 200 minus V21 is equal to I into I, 80, plus 30 into 1, 30. So we need V21. So V21 is equal to 200 minus 110, that is equal to 90 volts. Look at this, at origin it is 200 and at 21 it is 90. That means the potential is going to be decrease. And here also in the field, in a parallel field, the potential is going to be decreased when you are going in the direction of the field. Hence the potential at V21 point is 90 volts.